So thank you for joining us. This morning's webinar is packed with information. It is RLE Services, and they're presenting tips and tricks that they've learned through installs, tech support, working with our products. This morning, I have Eric Kelly. He's our Technical Service Manager at RLE. He does technical support. He's done quite a few field installations, works with our service offerings. Prior to RLE, he managed operations at a Tier 2 data center and managed 24/7 NOC at a local ISP. We also have Brian Jones. He's our Firmware Engineer at RLE Technologies. He also has done field installs, answers a lot of your tech support calls. He internally does QA and internal tests for our products and hardware and firmware design, and we are very glad to have him with us this morning. As far as our agenda, we're going to start with a brief introduction and product line overview from RLE's products. Then we're going to look at some general troubleshooting basics that we see across our product lines. They're going to dive into a little bit of product line specific troubleshooting. So they'll go through product line by product line and talk about some of the tips and tricks they have for those lines. Then we're going to take a brief look at our services division. It's kind of our ultimate tip and trick to make install easy and definitely hands-off for you. And then at the end, we will have time for Q&A. So if you have questions while we go, if you click the chat button at the bottom of the pane, you can go ahead and type your questions into the chat. I'll manage those and field them at the very end. You can send the chat to everyone, or if you have a question that you want to ask that you don't want to put in the public chat, you can send it directly to RLE, and I'll grab it from there. So with that, Eric and Brian, I'm handing it off to you.
Thank you, Jenny. As Jenny said, my name's Eric. I am the Services Manager here at RLE. And to get things started, we're going to do a brief kind of overview of our product line so everyone's on the same page with what we mean when we say Triad or C-Hawk and what that product line entails. The newest line that we have is the Triad line. That was a recent acquisition here in 2017. It specializes in data center airflow management products. So that could be raised floor tiles, the pedestals to hold them up, hot cold aisle containment, underfloor plenum, panels, grommets, foam, that sort of thing. Our C-Hawk lineup focuses mainly on detection of leaks. So that includes liquid sense cable, zone, and distance read controllers, spot detectors, and things that help you kind of detect a leak. So cable types, so on and so forth. And that's everything from small residence to large commercial buildings. The next couple lines we have are Falcon and Raptor lines. The Falcon products are designed for management or monitoring of a facility. You can then map, monitor, and or aggregate data and pass it off to another building management system if you have one equipped. The Wing Manager is another one that's in there as well. It's a wireless sensor option. It allows you to basically quickly deploy sensors to an environment without going through a whole bunch of cabling, install, and setup for that. The newer line products that are like wireless airflow, velocity sensors, differential air pressure, leak detection, so on and so forth. And then our Raptor line here is the type of products that help you integrate. So if you have legacy equipment that talks Modbus, and then you have a new BMS system that talks SNMP, a protocol converter can convert that legacy equipment into some communications protocol that your new building management system can use. From here then we've got ways to add just leak detection or sensors into an already established monitoring environment there. For getting into the technical stuff and just jump starting, I'm going to turn things over to Brian and let him talk about tech support for now.
Thanks, Eric. So if you have an issue that seems clearly firmware, we recommend you go to our website, rletech.com/docs. Our firmware updates are available there for free. If you can't find what you're looking for, we definitely recommend you contact tech support for a few reasons. We can help verify that you have the correct firmware going on your device. There may be a firmware we have in development that we just haven't posted online yet. And also, I know for some customers, it's really important to know exactly which changes are happening in the firmware, so we can provide a change log of exactly what's in that package. And then, of course, if you have a new feature request or bug that we may not have seen yet, we just appreciate that feedback. Another common scenario is we see people trying to send SMS messages from their leak controllers. So you could do this by using like a custom application to monitor the data and some more hardware, but a workaround we've seen used really successfully is using the carrier support to send email to SMS messages. So a few examples below, you can use those templates to send messages. There is a trick here though. You need to make sure you're connected to the internet to be able to take advantage of that service. And then starting off, just can you connect to the device at all? So first of all, just check the default IP address. For a lot of our equipment, it's 10.0.0.188, but check the datasheet. You can also access the debugging ports on the controllers to look up the network configuration. And then if you're still having trouble, we recommend disabling any Windows network adapters that you aren't using. Jumping around here. Okay, so one of the most maybe common things we see with leak detection is a not isolated controller. So you can see, from this example here, if you have a controller that's grounded, what happens is if you have a leak or contamination later in the cable, it might cause that cable to be grounded to earth ground as well. And it creates an earth ground loop where if the controller sends a test current to get a measurement down the cable, some of the current will actually flow to earth ground instead of back to the controller, which can cause a few problems. So I would say the most unique and telltale problem you see from a non-isolated controller is that you'll see a leak reading farther than the length of cable installed. So for example, you have 100 feet of cable and your controller is reading a leak at 150. In my experience, this is always a grounding issue. You also might see sporadic or jumping readings. So it's normal to have a little variation in the reading, but if you're seeing changes 10%, 20% of the cable length, that definitely seems suspicious of an isolated power issue. And then I just wanted to reiterate the danger here of sometimes it might show up that the controller detects no leak at all. So even if there's water on the cable, so just something definitely to be cautious of. You see a number of our devices that require isolation there. RLE provides isolated power options, so we recommend you check our documentation and talk to our sales rep to make sure you're getting the correct equipment. You can also go out and try to find on your own an appropriate supply. Just make sure that you're looking for something that's medically or electrically isolated. Without that marketing, typically they aren't. Usually it's pretty clear if they are isolated. So there is a quick check you can do for a wall adapter. You can use a multimeter to measure the resistance between the input and output grounds. If it's really low, close to zero, then that indicates the supply is not isolated. But if it's really high, like in the mega ohm range, then it is isolated. So just should go without saying, but please don't try this on a live circuit. All right, so transformers. This is something we hear a lot, and it's a really sometimes difficult question to answer. So transformers are inherently electrically isolated. You can see from the diagrams on the right, the input and output circuits are not connected electrically. However, what can often happen is that the input might be connected to earth ground. You can see on the diagram on the bottom right, even though there is a transformer in this DC supply, the input actually is connected to the output, so earth ground is connected through. Then also, I don't have a good example of this diagram here, but sometimes the neutral or return from the transformer is connected to earth ground, so just something else to be wary of. All right, and I'll turn it over to Eric for a little bit with product-specific troubleshooting.
Thanks, Brian. Going to jump right into Triad here and then work our way through the product lines. Triad, as I said before, one of the newer product line, covers airflow and air management type of solutions and problems is what it addresses. And a few of the tips here I found work great for maximizing your savings, dropping your PUE number. Starting off, airflow and airflow tiles are a big thing. A lot of tiles I found are directional other than just straight perforated tiles. So make sure you're paying attention to how those directional tiles are installed. As you can see in the photo here, ours use stratification fins. So depending on how you set that tile will depend how much airflow is going up the rack elevation and how much flow is being moved through that tile. Obviously, in our stuff, fins towards the airflow are going to scoop more, fins away are going to lower it, which works great so you don't have to buy a whole bunch of different types of tiles. You can use fewer tiles and get more different ways of operating and cooling your data center with that. A lot of tiles as well, they do or should come with a airflow rating. This is important when you're trying to balance the cooling in your data center using a raised floor environment. Just keep an eye on those. A couple of the other questions I do get is, hey, how do I make the data center more efficient? What is the best way to cool the data center? I found, at least according to current research, two things. Basically, the best way to cool your data center is going to depend on the data center, but you want some form of containment. Hot aisle, cold aisle, whatever that may be. That's going to be the most efficient. It's going to save you the most money on your electrical costs. For example, one of the data centers I worked at previously, we shaved $70,000 a year in operating costs just by cleaning up and moving towards a hot aisle containment solution there. And you'll also want to develop a plan. You don't want to just kind of willy-nilly go in and start trying to fix things. Coming up with a plan that's focused on containment and that best fits your space is what I have found to be the best starting block. You then, once you have an idea, measure everything that you can. Even if it's just all you can do is temperature, start there. If you can't measure it, you can't then find out whether the changes you are making are benefiting or hurting you. Use multiple locations. Think about where bypass air might be causing problems and the sensor location itself. You don't want to put a temperature sensor in a SAN station's exhaust. You're going to get absolutely horrific readings that are not true to what your environment is actually at. So think about that. And then start with the simple things. Blanking panels, controlling airflow in the underfloor plenum with plenum panels, using grommets and foam to fill those cable pass-throughs and other leakage points will really help kind of bring everything to a good normalization and starting point for any other changes you make. Another big key is consistency. Many times I've seen data centers, specifically colos themselves, where you walk in and there was blanking panels used at one time, but they're not now. So you have large gaps, you have large leaks, bypass air all over the place, and that's just causing you to run your cooling systems more frequently or harder to try and maintain that level of cooling. And last, evaluate your changes and start over. This is a cyclical process, and you will be able to see, hey, did the changes based off your measurements of temperature or humidity or otherwise work? Can you adjust any attempts? Can you slow the fan speeds of your crack units down? What are the next steps that you can take there should start becoming more obvious. And eventually you will get to a spot where the big next step is going to be containment. Whether that's hot aisle, cold aisle, any form of containment is going to be better than none. It's going to just be more efficient in the long run. There. The next item here, or product line, would be our Seahawk. These tips and tricks have been acquired over a few years from many different technicians here. So keep that in mind, but there's always going to be something there. So if you have questions, please ask. As Brian said earlier, you're going to want to use isolated power supply first. That, as he said, a lot of problems we have found there. Another tip, perform maintenance. I know it sounds basic, but that is a big thing. Dirty cables, major construction where they come in and accidentally cut a cable or cover it in silicone that blocks the conductance or the sensitivity of the cable. We've seen all sorts of problems. So perform a yearly maintenance at minimum. Test the system, make sure it works so you're not surprised by anything. We have also a product called a weighted cable connector, which is great for adding a simulated 50 feet between cables or points. So if you're trying to set up a room and map it, and one room, the cable feeds from one room right into another, throw a weighted cable connector in there. That'll add that 50 feet of separation, so it's a clear sign when you get a footage reading of which room your leak is in. And another thing I found is if you're in the data center and you're using a Seahawk cable, leak detection cable, sometimes you run into space requirements where you can't put the cable or recommended 4 to 6 feet away from the discharge point of a crack or a craw unit that has a humidification cycle in it. Keep in mind that if you do have to go closer, it's doable, but you do have to make some changes on the sensitivity of the cable. Otherwise, you'll get false alarms from condensation buildup on the cable. Another thing I have found is really inspect the area that you're trying to detect leaks in. I have seen in my days everything from 10-gallon water heaters, water drainage piping from a roof, all sorts of other issues or piping that are unexpected in drop ceilings, attic spaces, and those I have seen cause problems. Specifically a condensation management system in a data center that overflowed and started raining onto a SAN unit. Talk about a bad day for that data center manager. So keep those things in mind. You don't want something that you didn't think about or you don't look up and see on a regular basis to cause you a problem there. When also running cable for pipes, let gravity do the work for you. You don't need to spirally wrap a cable around a pipe. You can run it just along the bottom. And if you have multiple pipes or you've got 2 or 3 pipes vertically sitting on top of each other like in a rack style system or mechanical system, you can run along the bottom pipe or in a zigzag motion in order to cover everything. Gravity is going to do the work. If there's a leak, the water is going to run down, it's going to hit the bottom point of those pipes, and it's still going to alarm and give you an alert to what's going on. So keep that in mind. As well, when working on mechanical systems, specifically chilled water systems, you be careful of the bare pipe areas, ball valves, pressure reliefs, other things that don't have insulation on them. If you're running a 40-degree Fahrenheit comfort cooling system and you've got the standard temperatures there, you're going to run into condensation points. Just be cognizant of that. And don't be afraid to think outside the box on some of our products. Our spot detector, for instance, I have seen customers use as a fluid level sensor. So in a mechanical water system where you've got an automated feeder system, they will place and submerge that spot detector into their fluid inside that tank to alarm when the fluid drops below a certain level. The electronics are potted and sealed. It's a great way to think outside the box there and use something that you wouldn't normally see. I'm going to now pass it back over to Brian for some more cable.
All right, Eric, thanks. Yeah, so you can see there's quite a few different tips and tricks we have for troubleshooting the cable and controllers. One of the maybe most straightforward and helpful is to connect the system ahead of time. Just installing, starting with the leader cable and ending with the end of line just ensures that you have all the pieces you need. It also helps to not install the system backwards. The cables only mate in one direction, and I have seen before where someone has installed a very long cable run backwards, and then we do provide a kit to switch the polarity back, but it's just an unnecessary piece of equipment if it's installed correctly in the first place. Another tip is to use shorter cable runs with more controllers. It just creates a more modular system that's easier to troubleshoot. And then also using shorter cable segments. They're easier to work with, easier to install, also easier to troubleshoot. If possible, we recommend using lengths of 100 feet or less. And then a lot of these pieces of equipment are installed in construction sites, so we just caution customers to beware. Construction can damage the cable, cut, or crush it. It can also contaminate the cable, causing a leak or contamination alarm. So I've seen, for example, a scenario where the system is installed, it's working great, and then at some point there's a constant leak on the cable. What happened? Fire caulking was installed around the cable, which is conductive and will just put the system in constant alarm. So this is a pretty costly mistake to make, but the good news is there's a pretty straightforward solution. We also provide non-sensing cable, so if you just run a short bit of that cable through a section you know is going to be fire caulked, that'll solve that problem. Another thing you will want to eliminate is that there's a problem with the controller itself. It's pretty rare, but it can happen. So you see, for example, a set cable relay button I have there. It'll simulate putting a fixed resistance in place of a cable system. So for this system, you would see 80, 60 ohms on each leg. So I've seen a case where there was lightning damage, and even running this cable test showed that it was actually showing up 0 ohms, so there was a fault with the controller itself. And then also just another technique for debugging the cable is using a binary search technique, where I'll cover a little more on the next slide. So I think the best way to demonstrate what I'm talking about here is just through an example. So in this example, I have 80 feet of cable, 8 10-foot sections with a break at 70 feet. On your controller, you're going to read that there's a fault, but that's all you know. You don't know where on the cable the problem is occurring. So binary search, what I'm recommending is you split the cable system in half repeatedly until you're able to find the section of cable with the problem. So in this example, if you cut the system in half with the EOL, you see the first 40 feet are okay, there's no problem. If you cut the remaining section in half again, you can see that the 60 feet is 60 feet are good. And if you cut the problem in half one more time, you see it's that 70-foot section of cable with the fault. So I just want to summarize, this isn't always the most convenient thing. It can be very inconvenient to get underneath a raised floor and troubleshoot this, but it does help. It's something to keep in mind. Just for example, here, instead of testing every section of cable, we're able to find the problem in 3 steps. This is also useful because you can use it in other troubleshooting, like troubleshooting an RS-45 system. Okay, so switching gears a little bit, I want to talk about mapping. So this is where you have a system that's up and working. Great. So this is an even better way to help you locate where a leak is occurring across the system. So the procedure of going through this is you simulate a leak at a known location and then mark where that leak distance is occurring on a map. So just make sure to test at the corner points or changes in direction of the cable. So it's also a useful maintenance technique. You can go through and use these points as like an annual means to go and just make sure the system is operating carefully. Something we see commonly, though, is just make sure you're accounting for simulated cable length from some of our other pieces of equipment. For example, you see our weighted cable connector, our spot detector, and X connector all provide simulated cable length. So if you look, for example, on the right, you might say the top left corner of the room would be maybe 15 feet from the controller. But when you have the X connector and spot detector in series, it actually is showing up more like 200 feet. All right, so what do you need when you want to go about commissioning or mapping this system? Well, I think the best way to go about it is with a cup or dish of water. It's just the surest way to ensure you're getting a consistent leak reading. We've seen people use towel or sponges, which is okay, but it's just not preferred. If you do go about using it, just make sure when you wring it, your water is dripping out and you're sure that there's a solid leak in the system. And it might sound a little silly, but actually make sure you have water with you. It might be a construction site without plumbing, so unless you want to use your own drinking water, I recommend bringing it with you. And then I also think you'll want floor plans or blueprints. It's helpful for a couple reasons. It'll help you navigate the site, understand the cable configuration, and also make sure you have a digital copy that you can upload to your controller. And you would upload that to your controller using a laptop and connecting through the web interface. So another thing just to have handy for debugging is debugging cable. For a lot of our controllers, it's a 232 cable. You might, if you have a laptop, need a USB to 232 converter. So I just want to warn you, make sure that you have the drivers installed beforehand, because you might need access to the internet, and a remote site, you might not have that. I'll turn it over to Eric for a little bit with more on the Falcon.
All right. So as stated before, Falcon is a product for facility management and monitoring. And so looking at that, there's a few things that we have found. Specifically in this year's time frame, with a lot more people working from home, we've seen an increase in VPN issues. A lot of our equipment devices have the ability to change the TCP segment size of the packets that go through and are generated by the device to be a smaller. This really helps in VPNs and other network instances where having a larger packet just isn't as conductive or reliable, specifically when working from home or on remote locations. So if you do have any questions or problems with that, give us a call. More than happy to help as well on that. Another thing that we found just for ease of use, specifically in a NOC type environment or something where you need a quick access, I've got 10 seconds to read the screen, is grouping your alarms and your sensors on the home page of an FMS unit. You can see in the picture there, group 1's all temp sensors. You know exactly, okay, if it's group 1, it's temp, we've got one problem, I don't have to worry about anything else. That just helps speed things up quite a bit. Another interesting thing, the relays on the Falcon or the FMS unit, they can be controlled through numerous means. An input through like Modbus, a schedule, or through a button, a digital button on the interface or GUI of the FMS device itself. And we put the schedule on there because it's great for those items that you're only using maybe once or twice a month, but you still need to run intermittently. A pump in a chiller plant or a chiller itself. If those devices are legacy pieces of equipment and they don't have an automated schedule to turn them on, spin them up for 15, 20 minutes once a month or so, having a relay to do that has been quite beneficial to some of our customers. Also, we do have email logs on the unit so that if you are trying to send an email or a email to text message, something like that, and you're having a problem, make sure you go in and check the logs. It will show the mail server's response if you're getting a 502 error or what other type of issue you may be having. Really quickly narrows down, is it an issue on the device? Is it an issue with, say, my mail provider, or is it somewhere else along in the chain there? To shift gears a little bit here, looking at the wireless or wing manager, the wireless sensors and things like that, there's a few things you'll want to keep in mind when setting those up. First off, the wing TH can do dew point calculation, but it is not default to show up on the home screen. You do have to enable that through the menu. So if you are looking for dew point, specifically in, say, a data center or other place where that is a critical thing, make sure you enable it. It's pretty simple on-off toggle in the settings there. We do also have the ability to add sensors one at a time or as a whole with the auto detection. A lot of times in colo spaces, if you've got sensors on, say, a customer's cabinet and you're providing some sort of uptime guarantee in regards to temperatures, things like that, it's great to have those sensors there. The problem is, as we all know, the doors get taken off, the sensors get bumped or kicked, or when a customer rolls their whole cabinet out, the sensor goes with it. You can change the serial number in the manager without going through and changing the sensor's location in the chain or any of the other information that may travel up to another BMS or NMS system there. And one thing to keep in mind is signal strength. Wireless, the joke has always been, it's a little bit science, a little bit magic from time to time. And there are a few things you can do to really help get that working for you in a way that makes sense. You want to make sure everything is on the same channel, or a sensor is talking to a device on the channel it's supposed to. Whether that, as you can see here, is channel pair 1 or 2, you also want to make sure it's on the correct radio frequency. Outside of the United States, the 868 megahertz range is common. Inside, it's 900. And we haven't had any issues with stuff changing, but keep that in mind. Sometimes if you reset a sensor, you will have to change the channel pair before it will communicate. Also want to make sure if you're using a range extender that it is also on the proper channel. If you have multiple managers and each of them are operating on different channels, it's great to reduce the noise and the conflict between the managers, but sometimes when you set up a new sensor, you do have to remember, oh, it's on channel pair 2, let me make sure and change that real quick. Another big thing is the antenna alignment. As you can see in one of the pictures here, you want to make sure both antennas are parallel. Whether that's vertical or horizontal is your choice. Just try and make sure everything is parallel. It's a little bit of help, but sometimes when you're working with an area that has a whole lot of Faraday cage-like interference or a bunch of EMI coming off of pump motors or any other electrical noise, having that little bit just helps reduce the load on the sensors and on the manager, which equates to a better signal strength there. Also, the antennas can be moved on the sensors to come outside the sensor itself. So if you're working on a high noise environment, go ahead, open up the sensor. It's a real easy 2 clips that you can open up, and just rotate the antenna around and fish it through one of the housing holes, and boom, as you can see in the picture, it comes out. You have an extra 2-3 inches of antenna that can help boost that signal around. Also, when installing either a range extender or a manager, think about the environment and try and centralize the manager or the extender in the wireless network area, or in this case, what you are creating that wireless network. The sensors, you don't want to put a wing manager or range extender at one very edge and then have to use multiple range extenders to move that device around or to propagate that signal strength. So by centralizing it and then moving your antennas, it helps quite a bit there. And we do have, or we have seen customers extend the sensor or the antenna depending on the area. So if you have to put your wing manager in a rack, but you need to move your antenna that's attached to that, there are ways that we can do that. Give us a call, more than happy to walk you through that. The last item here is our Raptor line. And it is, as mentioned, devices designed to quickly implement or help add other types of sensing equipment to an already established BMS system. These can be things like our BMS wing for our wireless sensors, or if need be, we have other things like a relay duplicator or a remote annunciator that can easily go in, duplicate relays that you already have or adding. We do also have one wire sensors, such as temperature and humidity, that are wired sensors that can be added. Same with leak detection. We have systems for leak detection that can quickly be added in there. And one of the neat pieces of equipment is a protocol converter we have. Great for legacy devices where you've got legacy equipment, you've got new building management system, or vice versa, and you need a device that can aggregate a whole bunch of points from, say, a Modbus or some other type of 485 communication and transfer that over via SNMP. So keep that in mind. And again, then turn it over to Brian for some more Modbus and BACnet specific troubleshooting.
All right, so continuing kind of chronologically in this installation process, one of the final things that could be across any of our product lines is you might want to integrate the data from your controllers back into a BMS or BMS system. So absolutely one of the first things you want to do is just to make sure the proper protocol is enabled on both like the master and the slave devices. You also want to make sure that device ID is unique so that you're getting the correct response and also not duplicate responses from your devices. Especially with Modbus, I see issues reading the wrong registers. So I think it can be, for example, quite natural to assume a 40,000 block register would be function code 4, where in reality it's function code 3. And then also another thing that can happen is what I'm calling an off by 1 error. Sometimes the documentation for Modbus and other pieces of software is not well standardized and can be base 1 or base 0. So if you're not getting the reading you expect, try just offsetting by 1. And you might have a system that's working but slow. So one of the things you can do, I know it's not possible in every application, you can try to reduce the number of devices on the trunk. For a TCP IP system, that would look like shrinking the subnet. And if you're using BACnet, you can also lower the BACnet max masters property to reduce the searching. And then there can be a few things that can go wrong with RS-45 when you're wiring. So we'll just cover that on a later slide. Okay, so just good practice when you're setting up a system is to read a known quantity. I think it can be very tempting to go exactly for the data you're looking for, maybe like a leak status register, but it can just be so useful to read a manufacturer name, date, firmware version, just to give a lot of confidence that the system is working correctly. And if you're using an RS-45 system, you can actually get a lot of information from the LEDs. On our equipment, we have a lot of these dual stacked transmit receive LEDs. So if you're not getting any receive at all, that probably means the protocol is not enabled on your master device. You may also have broken wires where there's no communication getting through. If the transmit's not illuminated, that means the device or controller is not responding. So just make sure you have protocol enabled on that device. Check that it has the unit ID you expect. You also check to make sure you don't have the wrong wire polarity. And of course, you'll want to verify your serial settings like the baud and parity. Okay, so as promised, here are a few things that can go wrong when you're using 485. I tried to order this list from maybe most severe to least. So starting off, if you have the wrong polarity wires, you won't be seeing any communication at all. And by wrong polarity, I mean you have the AB wires switched. If you have frayed or a loose connection, you might just have intermittent communication with your devices. Actually see a fair amount of questions about what cable to use. We recommend 22 gauge or larger. Twisted pair is best, especially for environments with a lot of electromagnetic interference, will just help to mitigate those issues. And then if possible, use a shielded cable. Which protocol to use? The best you can use to limit interference is the bus or daisy chain. Also, I see a lack of termination resistance. So in your daisy chain, you want to make sure the last device on the chain has that termination resistance enabled. And a lot of our pieces of equipment, it's a switch that you can disable or enable. And then also finally, just make sure that the grounding is correct. Actually, similarly to the leak situation I was describing earlier with the earth ground loop, if you ground your system at multiple points, you are creating ground loops. So just make sure to avoid that. So in summary, I think a good solution is to use TCP/IP. It helps to eliminate any problems because you have the common Ethernet cables, so there's fewer wiring mistakes. Also, if your devices are already networked together, the implementation is really quite trivial. And even if you, for your application, can't use it in production, it is just a useful tool for setup to make sure that initial communication is working as you expect. So now I'll turn it over to Eric for a little bit to cover some of the ways that RLE can help you.
Thanks, Brian. And yeah, we're going to go over what the RLE Services division is and the product offerings that we have here. The services division here is basically anything that has to do with on-site training, tech support, startup, commissioning, installation, or phone call troubleshooting from there. So I'll cover each one here a little bit and give you an idea on how we can help make your life easier when dealing with new installations, rip and replace, or training, whatever that may be. One of the more utilized services here that we have is our installation services. We've got a very capable and knowledgeable team that's able to install all our products in a timely and efficient manner. Whether it's, like I said, new construction, rip and replace, upgrade, or residential, we got you covered. The biggest thing that we bring to the table here is peace of mind, in my opinion. For those with vested interests in the equipment that don't want to have that late night thought of, hey, was it installed correctly? Is it tested? Was the mapping set up properly? You can have factory trained technicians on site to help make sure everything is working before all parties sign off on said system. We also work with the managers or the building managers or the people with vested interests in the system on site to come up with a plan of action before we dispatch. Configuration worksheets, the statement of work, and as you can see on the screen there, kind of a blueprint for what you want and where you want the systems installed helps make sure everyone's on the same page for that. And we're also quite flexible. We have gone from initial phone call to on-site in under 48 hours. If things have gone completely wrong or a system needs more work than what was initially thought or plans change, as they always do in construction, we can extend our time frames. We do what we can to work with you and be flexible to make sure we can get everything up and running and and come to a mutually beneficial resolution there. Next is our startup and commissioning. If you already have a product installed, we can come in and we can do a startup and commissioning services for you. This isn't just a look at the stuff, oh yeah, it's installed and walk away. No, this is in-depth testing, mapping, and checking of a system that best practices were followed, that the system is working, and it's tested repeatedly during the mapping process of that. We want to do a few things here. Test the system and load it up to make sure it's working as it has been designed and built, and to make sure that anyone who has any interest in maps or the communication of that device to another building management system, if so equipped, is functioning properly. We do inspect cable. We make sure anything that happens during construction, such as, hey, the air handler guys came in and bumped a cable or cut a cable, we make sure all that stuff is taken care of and get you up and running quickly. We also do have on-site tech support. This is great for if you're a smaller company, you don't have the personnel to take off of another task and move to dealing with a leak detection issue or a building management issue with one of our devices. We can come on site, diagnose, replace, repair, and get things running. If a motherboard is bad, if you need firmware updates or a hard reset, whatever it may be, more than happy to help you there. And lastly, we have our on-site training. This is training that we can provide for either tailored systems, if you just want, say, our leak detection or just our building management services or our Falcon units, or our entire product range. We can come out on site and train you on how that product works. This is not a sales training, it's an in-depth tech training to go through and make sure that your techs feel confident in working with our equipment. The training was set up in the kind of the way I learn, which is I see it or I read about it, and then I want to be hands-on. I want to pull the systems apart. I want to potentially crash the systems. I want to get them back working again. And we provide that by bringing equipment on site, so your techs aren't learning on equipment that has been installed or is in production. And I'm going to throw in a little blurb here about COVID as well. With the drastic changes a lot of us had to go through with restrictions on travel, things like that, we do, like I said earlier, try to be as flexible as possible. Whatever that means in your specific scenario can change, but having a technician virtually walk us through your data center for a walkthrough or a troubleshooting issue or whatever it may be, give us a call. We're more than happy to do whatever we can to think outside the box to get you up and running quickly. And with that, I'm going to open this up to any Q&A. Also, my contact information, where you can find documentation, is here. So if you do have any other questions, please reach out to us if we can't get to it in the time that we have left.
Thanks so much, guys. Sorry, Eric. We have a couple questions. If anybody else has anything they'd like to discuss, please throw it up there in the group chat and we'll address it. So Eric and Brian, here's a question that came to us, sent to us directly. I just inherited a device and I don't know the IP address and I can't access it. How do I find out what the IP address of the unit is?
So, great question. It does depend on the device in question. For instance, our leak detector, the LD2100, you can push the reset stop button a couple times and then hold it down and it will read off what the IP address is on the unit. For a lot of our other units, you can use a console cable or a null modem serial cable, and you can console into the device and find what the IP address is. That's IPv4, and you can reset or change that if necessary.
Thanks, Eric. It seems like inheritance issues are something that a lot of our users have here. The next question is, I just inherited a leak detection system I'm not familiar with. Where can I go for information?
Yeah, so I I'd say that link on the page, rletech.com/docs, that really is the most complete source of documentation we have. Everything's all right there. If you have any questions, well, those are our personal emails, but also that support email, that goes directly to our inbox. So if you don't know which one of us to direct a question to, that's just a good way to get in contact with us. And we're always available, so, please don't hesitate to reach out. We'd much rather see customers reaching out with questions before there's an issue, before it's too late.
Yeah, don't spend a ton of time, multiple hours or days working on a problem. Give us a call, shoot us an email. I'm more than happy to get you on the right path quickly so you're not wasting time.
One more question for you guys. We are almost at the end of our time, but I think this one's a good one. The submission says, my leak detection controller seems to be more accurate when on a UPS versus when it's connected to the wall.
Yes, I'll take this one. That is correct. So a lot of times what we'll find is the power will be somewhat variable. I see this less in data centers when the units are connected up onto a larger UPS that's doing power cleaning and whatnot. But that's essentially what's happening. The small UPS that your system is connected to is making sure any of the power fluctuation, brownouts, low voltages are not hitting the controller. And that can cause a little bit of jumping around in footage or some odd behavior from time to time when it's getting a quote-unquote dirty power versus a cleaned power. That's why you'll notice those odds and ends there.
Thank you so much, guys. We are about at the end of our time, so we are going to conclude our webinar unless anyone has any other questions for the group chat. And if you find that you do have questions later, please feel free to email our support team. They're happy to talk to you about questions or issues you're having. And so you all know, we have recorded this webinar. It will be available on the RLE website if you need to go back and reference anything that was discussed today, or if you have anybody you want to share the webinar with, it will be available for you. So thank you so much. Thank you to Eric and Brian for all the time and energy you put into your presentation this morning. We appreciate you sharing your knowledge with us. And thank you to all our participants. It was great to see you here this morning. Have a great day, and thank you for tuning in.